Hey, hello everybody. Welcome back. This is Mr. Geiselman talking about electrical production today. So, hopefully, you got everything you need. Here we go. So, how is electricity produced? That's what the topic of this Ed puzzle is going to be today. So, when we look at electricity, no matter the method of electrical production, there's a series of steps that are used to convert between different forms of energy. That can be as simple as solar, mechanical, chemical, thermal, electrical, or nuclear, or it can be steps between each. We can go from chemical energy to mechanical energy, or chemical to thermal to mechanical to electrical. There are ways that we can convert different types of energy. You and I do it every single day. The food that we eat has stored chemical energy in it, and as we move around, we are converting that chemical energy into mechanical energy or movement energy. We convert a lot of our chemical energy that we eat into thermal energy as we keep our body temperatures up. And that's how electrical production actually works. Is it's a step-by-step process of converting different types of energy. So your traditional power plants are going to use some sort of water heating system. Water is going to be heated by some system that turns into steam. That steam builds up a lot of pressure and it's going to spin a turbine. A turbine is it's like a propeller on a jet plane. That's why they're called jet turbines. So when that spins, that turbine is going to spin a generator. And as you learned yesterday in the Ed puzzle, a generator creates alternating current, all right, in electricity. And that can be transported a long way. There are other methods. Wind and water use uh, wind and water to spin the turbine instead of that steam. And then there's some other things like solar that use photons and they transfer their energy to the electrons inside of a solar panel. And we'll talk a little bit more in detail how those work. So your traditional methods of generation are going to be coal, natural gas, and other types of burning power generation. Biomass would fall into this as well. So some sort of fuel source is burned. This could be coal being burned, as in the picture. It could be natural gas. It could be biomass. And biomass is just living things like wood and other debris that was flammable. Nuclear is also used to heat water. So we're having a nuclear reaction, a fission reaction take place, all right? And we're converting that chemical or nuclear energy into thermal energy. So we're heating something. And what we're actually doing is we're using that heat energy to change water into steam. That steam then pushes the turbine because that steam generates a lot of pressure. As it moves past the turbine, and remember, a turbine is like the blades in a jet engine, that thermal energy spins those blades. And that steam, right, the thermal energy converts it into mechanical energy or energy of movement of the blades of the turbine. That turbine then spins a generator. A generator takes magnets and a coil of wires and spins them around to convert that mechanical energy into electrical energy. Wind and hydroelectric are fairly similar. We are going to skip the chemical to thermal stage or the nuclear to thermal stage, and we're going to go straight to the spinning of the turbine. Now, the wind or the moving water is going to be the thing used to spin the turbine. In a hydroelectric dam, water is going to be let in at the top of the dam. It's going to fall down. Its energy is going to come from potential to kinetic as it moves down. And it's going to spin a turbine before it's let out into the rest of the river. That turbine will spin a generator that is then shipped off as alternating current electricity. Wind also is going to be pushing on the propeller blades of a wind turbine. The wind turbine, right, the blades are the turbine. So now instead of using steam, we're using wind. And inside the back of our wind turbines is a generator. And that generator is then spun to create electrical energy. So we are taking, in both cases, the mechanical energy of moving wind or moving water and converting it into electrical energy. Solar is a little bit different. This one is actually quite a bit different than the other forms of electricity that we've talked about. So sunlight hits a solar panel, and that sunlight uses what it's called photons. That's the particle of sunlight, all right? And that's used to excite electrons inside of a solar panel. The excited electrons move around the solar panel. So once the sunlight hits them, the electrons become energized and excited. They start to move, and as we remember, moving electrons equals electricity. This creates direct current electricity that can be used. So if we want to charge up a battery, or if we want to use it in a device, we can use it right there. If it needs to be shipped out, and if it's part of a solar farm that's collecting energy and being shipped to the grid, it needs to be converted into alternating current before it can be transported. There are also a few other forms. The picture above, we will watch a quick video about. This is solar thermal energy, where we use the thermal energy from the sun, not the energy of the photons, to create electricity. And down on the middle right side here, we have geothermal. Geothermal uses hot water from that has been heated by the earth to create steam. That steam then spins a turbine. That generator is spun off of the turbine, and that creates alternating current electricity that can be shipped out to everybody. But down below, we're going to take a quick 40-second look at the video.
For electricity production, high-temperature solar thermal systems called concentrated solar power, or CSP, use roofs and mirrors to concentrate solar energy on a central collector. This produces temperatures high enough to generate steam, which then turns a turbine, driving a generator to produce electricity. CSPs are primarily found in desert locations where space and sunlight are abundant. One advantage of solar thermal energy production is that it is clean and renewable.
So that is solar thermal. That's kind of one of the cool newer ones. If you have ever been to Arizona, Nevada, parts of California, and Utah, you will actually see places like this. And just a quick refresher on how most other types work.
Fuels like coal, natural gas, biomass, and uranium are used to heat water until it produces steam, which powers a turbine and generates electricity. That steam turns propeller-like blades around the rotor inside the turbine. This turning rotor connects to a main shaft which spins magnets with a coil inside the generator. It's the generator inside the turbine that converts mechanical energy into electric energy and creates electricity. Steam is an efficient method of producing electricity because the water can be recycled and reused as it changes back and forth between liquid and gaseous states.
So again, that's the traditional method. Now, you probably already know, each method has its pros and cons, and that is something we can dive into later on in class. If you have any questions, please let your teacher know. Otherwise, have a fantastic day, everybody.